connectivity. I hope that it will become better. Okay. So, okay. So let me start. As AM sir has already explained the basic setup, so I have to explain, like we have to explain that how the measurement is done, and then about the detector part and the SWR meter part. Okay. So I will also explain from the beginning. Just I will touch the things because sir has already explained, and then we'll focus on these two parts. Okay. So I think you all can view the basic test bench setup on your screen. You
Yes,
all are
sir.
able to see the, yeah. Okay, so this is the basic test bench setup. Okay, so the basic components I will name one by one and just explain in few lines, one or two lines, and then we'll come to how the wavelength is measured. Okay, how the frequency is measured, uh, then the crystal detector part and the SWR meter part. Okay, so first and the foremost important thing about, so the first and the foremost important thing in this microwave setup is the microwave source. Okay, so we have the first component as the microwave source that you can see. Okay, now you can use klystron as the microwave source or gun as a microwave source. Okay, because you must have, wait for a few minutes. Yeah, sorry. Yeah, so you have, first you have microwave source. You can have my klystron as a microwave source or gun as a microwave source. Okay. Now the basic difference between klystron source or gun source is that klystron is a tube device, microwave tube based on tube technology. However, gun diode is based on solid state device. It is actually a solid state device. Okay. Now using klystron, when I am saying microwave source, so basically we are generating microwave signal. Okay. So the klystron and the gun is used in a microwave oscillator. Okay. If we are using klystron, then we say it is a klystron oscillator. And if we are using gun, then we say it is a gun oscillator. So this covers the microwave source. Now, next to microwave source, we have isolator. Okay, as sir has already explained the working, how it is constructed, isolator, and sir has also explained that it is a unique, uh, like uh, it is a one-way device, any unidirectional device. Like it will allow microwave power to go from microwave source to reach to the pin modulator, but it will not allow the microwave power to reach to microwave source. Okay, so this is isolator. Now next, to microwave oscillator, we need modulator. Okay, so we use pin modulator to modulate 1 kilohertz of massive signal over the carrier, which is generated by the microwave source, because the microwave source is in gigahertz range. So now if the microwave source produces gigahertz signal, then at the detector end also you should have like a detector which would detect this signal. Okay, so that's why we need a modulator, uh, because at the detector end, what we are going to do first, we are going to detect the message signal. Okay, low frequency detector we use. Okay, so we use pin modulator. Okay, pin modulator, what does it do? It modulates a square wave generator with the microwave source. Okay, and then next to pin modulator, we have a variable attenuator. What does variable attenuator do? That has also been explained by sir. Sometimes you have to adjust the sensitivity. You have to adjust the sensitivity of SWR meter, as well as sometimes you need to match impedance match the crystal detector. So for that reason, variable attenuator is used. Also, in a general sense, it is used to attenuate uh, the incoming power of the incoming, okay, signal. And then we have frequency meter, which is used to measure the frequency of the incoming signal. It is actually a cavity resonator, cylindrical cavity resonator. Okay, I do not have images, individual images of these components. Otherwise, you would have understood it properly, or at least you would have realized it in a better way. Okay, so it is of cylindrical shape, and it has markings. It has markings on its circumference, outer boundary. Okay, and then it has one vertical lining. By the way, Bhanu, are you there? Bhanu?
हाँ सुनाई दे रहा मणि
हाँ,
हेलो
हाँ, Bhanu,
I will just share I will
can
just
you
share
search image of, yeah,
yeah I'm doing I will just share.
So can we
yes.
go back to the pin modulator for a second, because I see the arrow coming from the universal power supply to the square wave generator
Wait,
to the pin modulator.
wait. See, wait, I will explain universal power supply. What is universal power supply? That I will explain. See, to make this workbench running, you need power supply. So there is one power supply. There is, using that you feed microwave source as well as a square wave generator, and that's why it is called universal power supply. Okay, yeah. So yeah, see, this is frequency meter, as Vanu has already shared his screen. Okay, so you could see it is cylindrical in shape, and then you see black cap on the top of the frequency meter. Okay, so when you will rotate this black cap, okay, and then you see red marking, two horizontal uh, red markings and one vertical red markings. Okay, so what will happen that, and then you see the scaling, okay, so it can measure actually frequency in the x band range. So x band range basically typically from 8.4 to 12.2 gigahertz. Okay, so it can measure frequency in this range. Yeah, Banu has also marked. Okay, and then you see you give input from the input end, you can, and then you will take from the output. Okay, output from the right hand side. You can do it, other way also. You can give your input power from the right hand side and take the output power from the left hand side. Okay, there is no absolutely no difference. Okay, then it is a very high quality factor. Okay, circular cavity. Now you all know, or might be you all have studied in your microwave course, that if it has a high quality factor, then its bandwidth will be very narrow. So it's really narrow, very narrow band device. Okay, so when you will turn the upper black cap, okay, clockwise or anti-clockwise, the vertical marking and the horizontal marking will move. Okay, sorry, the vertical marking will move accordingly. Okay, and how will you read this? How will you read this frequency meter? So you see, there are two horizontal red lines, and then the horizontal red lines, and in between these two horizontal red lines, you see the markings. Okay, so the markings which lies between these two horizontal lines and and is intersected by this vertical line. Okay, that is the reading of this frequency meter. Okay, in gigahertz. Okay, the unit will be gigahertz, right? Have you understood? Have you understood how will be read the frequency using frequency meter?
Sir, could you like I understood that we will rotate it and the uh, markings
See,
will move, but
when you will rotate, na, the horizontal markings will go up and down. Okay, the horizontal markings, the vertical marking will just rotate. Okay, when you will rotate, the vertical marking will also rotate, but the horizontal marking will just go up and down. Okay, now suppose you want to read the frequency which is shown by the frequency meter. So you could see there is a marking which is between the two horizontal lines. Okay, right now in the current image only, you see the two horizontal red lines, and in between that horizontal line you see the markings, and then that marking, between that marking, the vertical line is intersected by one of the reading. Okay, one of the readings in
yes, sir.
between these two horizontal lines. So that reading which lies between these two horizontal lines and intersected by these vertical lines, that is the reading of the frequency meter. Okay,
So, sir,
understood?
any marking on either of the two, like horizontal, there would be two horizontal lines which intersect
Yeah.
with the red horizontal line, and
Yes.
the reading, like the marking with which the vertical line intersects on any of these two lines will be my frequency reading.
No. See, in between these two horizontal lines, you see only one reading. Okay, you see only one reading. I'm not saying the top. See, between these two horizontal lines, you see
Okay, okay,
the
sir. Yes,
readings,
sir.
readings which is attached to the lower
Bottom.
horizontal
Yes,
line,
sir. Got it.
not the vertical horizontal line. The marking which is attached to the vertical horizontal line. Sorry, top horizontal line. Yeah,
Yes,
Banu
sir.
has
Got it.
also marked. Yeah, you have to read that.
Yes,
Okay.
sir. Yes, sir.
Yeah. Yes. So also, another important thing, that when you are modulating your signal, because before that you had attenuator and before that you had pin modulator. One important thing regarding modulation, that you have to adjust the modulation index. Okay, you will have to adjust the modulation index. Now, so okay, so you will have to, how will you adjust the modulation index? So somebody has asked that what like there was a block diagram called universal power supply. So in the universal power supply, what you do, you have one output for microwave source, one power outputs for microwave source. Okay, and then in the universal power generator, the a square wave is generated in the universal power supply only. Okay, and then the frequency and the amplitude of the square wave generator is also controlled using the knob which is there in the universal power supply. Okay, or the generator. Okay, so using that, yeah, it has shown. So you see universal power supply, one output from universal power supply is connected to microwave source. Okay, so you are actually giving power to the microwave source. Then universal power supply also generates a square waves. Okay, so a square waves frequency and amplitude. It will have frequency, means it will have time period, and it will have amplitude. The amplitude and the frequency is controlled by a knob. You will find that there is a knob in the universal power supply, and it is when you will see the like instrument, it is self-explanatory. You will find that below the knob it is written that a square wave amplitude, and then a square wave frequency, and then uh, like voltage for microwave source. Okay, then also you need to understand the sources, like the power supply for klystron and the gun source differs a little bit. Okay, for gun source you need gun bias voltage. For the klystron you need repeller voltage as well as beam voltage. Okay, so klystron source bit difficult to handle. Gun diode or gun oscillator is easier to handle, very easy to handle. Okay, and klystron source is very sensitive to power supply variation. Okay, and also when you will do experiment, you will realize that when you are using klystron source, yeah, when you are using klystron source, you have to wait for few minutes, or maybe few minutes, maybe it could take 10 minutes or 20 minutes to stabilize the oscillations. Okay, however, this gun diode very quickly stabilizes. Okay, another thing is that this gun oscillator, when you are using gun diode in the oscillator, okay, so it produces uh, low microwave power. Okay, however, using klystron you could actually produce huge amount of microwave power. Okay, however, for this experiment, for this microwave test bench experiment, you do not require much power. Okay, uh, even using gun diode, you can produce I think 3 to 4 milliwatt power easily. I do not exactly remember the figure, however. Okay, so okay, and then yeah, so using this a square wave amplitude, a square wave generator amplitude and the frequency, you will modulate the signal. You will modulate the signal, and the modulation index, amplitude modulation is done, and the the modulation index or the depth of the modulation should be less than 1. Okay, otherwise what will happen? You will not be able to recover the uh, message signal or the square wave uh, perfectly at the detector end, and then the measurement, your measurement will not be proper. Okay, so this is very important. You have to ensure that depth of modulation index should be less than 1. Okay, I hope that you all have studied in the analog communication that if the modulation depth is greater than 1, then in case of amplitude modulation, a distortion happens. Okay. Uh, okay. So we have explained till frequency meter. Okay. So Banu, please share the next part. So any question till now? Any questions till now?
Will the document you're using be shared for later reference?
Sorry?
The document you're using,
Kushal.
the theoretical.
Sorry. Again. Kushal or Karthik?
He's saying that the document that you are showing, could you share it with us so that we can also see and get the things understand?
I I think Bhanu will share these documents with all of you. No problem.
Hello, Mani. Am I audible?
Yeah.
Hello.
Yeah.
Hello.
Yeah. You are audible.
Hello. Okay.
Bhanu.
You can find like you can just go and search online. There are like tons of materials available. Like we are just selected few documents, but there are tons are available if you go and search for online. Just search like micro test bench. You may get even better documents, like better materials. This is just a block diagram. Okay. Means whatever the things we have followed, we will try to share it with you. But however, you can just search it online. Okay.
I would also request everyone to search on Google virtual labs, which is which has been created by MHRD. You may find microwave experiments there as well. Virtual labs by IIT Kanpur. Okay, because see block diagram when I am explaining or when sir explains using the block diagram, okay, you will not realize the things properly. Okay, yeah. Typically, this is how the microwave workbench uh, looks like. Yeah, Banu sir. Yeah. Okay, so you see, yes. So this is, yeah, you see on the left hand side, you see this is actually the klystron power supply. Okay, on the left hand side you have actually the klystron power supply, and then klystron, because it's a tube device, so it gets heated very quickly, and lots of heat dissipation actually takes place, and that's why you see a fan, cooling fan. Okay, so this is actually the cooling arrangement for the klystron. In fact, we have both the gun power supply as well as klystron power supply in our lab, which you could see. And then you see one square box next to the power supply, next to the klystron oscillator. So you see that is the isolator. Okay, Banu, just mark it isolator also.
Actually, sir, if there is a virtual lab available, can you use that and show us instead what to do?
No.
That will be, I think,
Uh,
more beneficial to us.
yes, actually, we are just informed. Otherwise, we would have done that. And the virtual lab is not fully prepared. That's why. But you can get material there. Okay. So that's why I'm saying. You just write on Google virtual labs by IIT Kanpur. I think that you also need. We also need to create an account to access that. But you try that at least, because it's better. It's better to visit that platform, and then also you can search on Google definitely. Okay, for the materials. Okay, you just search virtual labs by IIT Kanpur, or you can microwave labs microwave virtual lab by IIT Kanpur. Okay, yeah. So you could see next to the klystron oscillator, you have this isolator. Okay, and then next to the isolator, you could see actually attenuator. Yeah, you could see attenuator. So in this setup, I could not see pin modulator. Okay, I could not see. Yeah, there is no pin modulator. Okay, so here you will not be able to see, but it is just like a rectangular box-like arrangement only. Okay, and then you have this cylindrical shape frequency meter. Okay, yeah.
Hello.
Next to the
Hello, Mani.
yeah.
Klystron, when you are using klystron, right, you don't need pin modulator. Means for gun, you need additional modulation, but klystron, it comes with its modulation also.
Yes.
Okay.
Yes.
Klystron doesn't require one.
Yeah. it is the you have to just select whether it is AM or FM in the power supply. Yes. Yeah. Okay. Yes, Banu is correct. Sorry. Okay. So when you are using klystron as a source, so it is already it comes like you have to just select with the AM. You have to select the AM modulation in the power supply, which is there in the power supply. Which I think the left on the power supply you could see klystron power supply. Okay, you the left sorry the right top black knob actually is for selecting whether it is AM or whether it is FM. So you have to set you have to select AM. Okay, for microwave set workbench experiment. Okay, then you have this frequency meter. Yes, here. Yeah, here you could see the right hand side klystron power supply. Yeah, you could see right hand side the AM and the FM or the continuous wave. So you have to select the modulation, that how do you want to modulate your frequency, like klystron oscillator. Okay, so you will have to select AM. Okay, and then you could see other knobs also. Okay, all are self explanatory. You see, I have told you the repeller, there are two things, repeller voltage and the beam voltage. And then you okay, so the repeller and the beam voltage, below this you have repeller voltage and the beam voltage. Okay, the middle one I think is the beam voltage, and the bottom, or yeah, this is no middle Banu, middle. Yeah, the middle knob is for beam adjusting the beam voltage, and the bottom one is for adjusting the repeller voltage or the reflection voltage. Yeah, both are same. Yeah, and then you could also see AM FM modulation. So you see AM amplitude and the frequency knob. So using these two knobs, you adjust the uh, modulation depth or the index. Okay, and then uh, like then you could see actually the in the display what is the supply voltage and the other things. Okay. Yeah, but go to that sorted line section. Yeah, this is the power supply for gun source or the gun oscillator. So you see it is very easy. Here you have gun bias voltage on the top right, and then you have this amplitude and the frequency, a square, like for a square wave, amplitude and frequency is adjusted by the bottom knobs. Okay, and then you could also see gun supply voltage is taken from the leftmost output, and the pin supply. Okay, pin supply output is taken by this rightmost output. Okay, and the voltage, you could see actually voltage and the current. They're next to the like left to the gun bias knob. You could see switch, and there it is written on the top, it is written B, and the bottom it is written C. So when you will select when you will take this switch to the upper side, then your voltage will be displayed, gun bias voltage will be displayed in the screen. And then when you will keep it down, okay, as in the current it is shown in the figure, then it will show the current which is drawn by the gun diode. Okay, it will display that. Okay, and the leftmost switch is just for power on and off. Okay, so this is actually the gun power supply. You will see exactly when you will see in your lab. Okay, so practically it will look like this. Yeah. Now, Bhanu, we can go to that slotted section. So, any questions till now? Yes. So, you could see uh, this cylindrical shape is a frequency meter. Okay. And then next to the frequency meter, one like waveguide uh, structure. It is actually a rectangular waveguide having slot, tapered slot. It is not actually a rectangular slot, but it is actually a tapered slot. Okay, width is maximum in the middle, and then as you move to the towards the extreme ends, it becomes narrower. Uh, so it is a slotted. Uh, Basically, it is called slotted waveguide section. So it is actually a rectangular waveguide having slot on the middle of the broad wall. Okay, so you know that the rectangular waveguide, one wall will be wider and the other wall will be shorter. So you have slot etched or cut on the broad wall, not on the narrower wall. Okay, and then you could see. Uh, Sorry, Banu, I think. Yeah, yeah. So this is how the slotted section appears. You see slot on the middle of the waveguide, and then you see one moving edge attached to this waveguide. From the one end, the power bill. This is the broad wall, okay, and the narrower wall. So you could see the slot is cut on the broad wall, okay, and then you see a moving carriage is attached to this waveguide. So you can actually move using this black like knob. You can actually move this carriage to the both ends of the waveguide. Okay, means along the slot. If you have any doubt and questions, you please raise. Okay, till now.
Mani, I will just share you the surface current picture, right? Just wait a moment.
Sorry.
I will share you the surface current distribution for the waveguide that will help you,
Yeah.
right?
Yes.
Just wait a moment.
Students, if you have any question, please raise. You can ask from whatever we have explained till now. Okay. Yeah. So the reason, yes. So the reason why lot is cut on the middle of the broad wall can be explained by looking at the current distribution on the different parts of the waveguide. Sir has already explained to you this very detail that why we cut the slot in the middle, because what do we want? We do not want radiation. Okay, so if we do not want radiation from the waveguide slotted section, then disturb the current distribution. Okay. So that's the reason that when you will look at the current distribution, you will find that the current distribution, the current density is minimum in the middle of the broad wall. So that's why it is cut in the middle of the slot is cut in the middle of the waveguide. Okay. Yeah. However, if you will cut, yeah, you could see that the current is not disturbed. Yeah, by a larger extent. It will definitely disturb, but very little. However, if you will offset the slot towards uh, the walls, like if you will not cut the slot exactly in the middle, but then in that case it will not guide the electromagnetic energy, but most of the energy will radiate. Okay. So at the detector end, the like the EM energy or the microwave energy, microwave power, okay, will not be strong, okay, enough to detect. So yeah, so it has Bhanu has drawn a slot offset to the uh, center. So you will see if you will cut slot here or anywhere, so you will find that most of the electromagnetic energy will leak out from the waveguide and it will not propagate in the forward direction. Okay, and sir has already explained. However, if you have read the waveguide, you just check the expressions for the dominant mode. Sir has also, by the way, sir has also explained that I think sir has also explained that which type of waveguide we are using in this microwave workbench experiment. So the waveguide we are using here is WR90. Okay, the name to this waveguide is WR90 waveguide, which has dimensions in inches, zero point 0.4 into point, uh, point 9. I think it's a little narrower wall than the broadband.
Excuse,
Yeah.
can't hear you. Like, I think your voice cut off or something.
Okay. Wait. Okay. Is am I audible now?
Yeah, this is better.
Okay. Let me adjust my microphone. So now am I audible?
Yeah, now it's good.
Okay. No problem. So what I was saying, by the way, we forgot to explain that which type of waveguide we are using in this experiment and the frequency range in which we can perform this experiment. But I think that this part sir has explained that we are using actually the X band waveguide. Okay, and then the dimensions of this waveguide, I think in the very first experiment also, in the beginning of this lab, Menal sir has also explained that why this particular dimensions are chosen, like for WR90 waveguide. Okay, uh, wait, it is like, yeah, zero point 0.4. So the waveguide dimension was 0.4 times 0.9 inches. Okay, you just Google it, that the dimensions for WR90 waveguide. Okay, and sir has also explained that in this frequency range, it supports single mode of operation. Okay, the WR90 waveguide supports a single mode of operation in the X band. Okay, so this we forgot to explain. So you can you can actually plot the current distribution. Okay, you can see, you can write actually the formulas. What are the dominant modes expressions dominant mode you all know TE10. Okay, where the first index A, like M, represents the variations in the broad wall direction, and the second index represents the variation, half wave variations in the narrow wall direction. Okay. No, it is for WR28, Bhanu, WR90. Okay. Another thing is that so when you are using the WR90 waveguide, uh, uh, with single mode of operation, you can actually find out the field expressions for that single mode, that is TE10. Okay, and then you can actually find out the current distribution by current distribution using that n cross like n cross h equals to j. Okay, so surface current you can find out, and then you can plot j, okay, on the walls, and then you will find that you have a minimum current density. In fact, you can observe this using this simulation tool which you have learned, HFSS. Okay, in the HFSS also you can actually visualize the current like surface current density, and there also you could see that the surface current density is minimum at the middle of the broad wall. Okay, yeah, so WR90 dimension is shown here. Okay, so waveguide, so see the dimensions, the practical waveguides comes is having like fixed dimensions, the broader dimension and the narrower dimensions. So we do not choose the dimensions at random. Okay, so this is the WR90 waveguide dimensions 0.9 times 0.4, and this is in inch actually. So you can convert it, you can multiply it to 2.54, you will get into centimeter. Okay, and the uh, operating frequency for single mode operation. Okay, you could see 8.24 to 12.40 gigahertz. Okay, and this is actually the cutoff frequency. 6.56 is actually the cutoff frequency. So you also, I think you all have studied about this in your microwave course, that like if FC is your cutoff frequency, so just after the cutoff frequency, you do not use the waveguide. Okay, at least 10% further frequency than your cutoff frequency. Okay, so 10% frequency, 10% of the cutoff frequency, you use your waveguide. Okay, so that's why here also the cutoff frequency is 6.56 gigahertz. However, the operating frequency range is 8.24 gigahertz. Okay. Yeah. Yeah, Vanu, you can now remove it. And Vanu, can you unmute your MIC, please? Yeah. So, what do we need to explain? Because I mean,
am I audible?
showing how to measure. Yeah, you are audible.
Okay. Till now we just explained all the things, right? After this one, we are left with the tuning probe. So how from the standing wave we will be getting the signal. It's how we will be using that capacitance.
Sorry,
capacity demodulation, right? Using that we will be taking out the.
Not audible properly,
we have to detect the signal, right?
Yeah.
Am I audible now? Yeah. Now
Yes.
we have to detect the signal, right? So we will be taking out the amplitude using this tunable probe. we will be using the VSWR meter. Okay.
Yeah. Okay. So okay. So go to, yeah, this slide is better. Okay, now you see. So you had frequency meter, and then we have that slotted line section, and then over that slotted line section you had one carriage. Okay, that is called probe carriage, because in this section you actually sample or you actually detect the incoming signal coming from the source. And remember, the incoming signal to the waveguide section is not just microwave source, microwave power, but it is the modulated microwave power, a square modulated microwave power. Okay, so you have over that carriage, you put, okay, you put one uh, probe. Okay, you insert through that slot which is cut in the middle of the waveguide. You actually insert a probe inside the waveguide to uh, take the microwave energy or to sample the microwave energy. Okay, and this is again circular, like this is also in circular shape. So, and then you see a diode is connected. So this complete section, by the way, combinedly known as crystal detector. Okay, this is actually known as crystal detector. Okay, so you using the probe, you actually capture the microwave power, and then this uh, this circular waveguide again. This circular waveguide is excited using this probe. Okay, and then you see on the you see you have a tuning salt on the top. Okay, so by adjusting that tuning salt, because again you all know, you all have studied maximum power transfer theorem. So you have to match the impedance properly for transferring the maximum power from the source to the load. So this is just a load. So this crystal detector. Okay, so when you are sampling the microwave power, you have to properly match the impedance for maximum power transfer, or so that crystal diode, your crystal diode or the diode could reasonably could produce the signal, reproduce the signal reasonably. Okay, it is actually demodulator. Okay, it could actually detect the a square wave. Okay, so using this tuning sort, we actually adjust the impedance for maximum power transfer, and then it is sent to diode. So what does diode do? It just acts as a diode detector. Okay, diode detector, AM diode detector, AM demodulator. Okay, AM detector or AM demodulator. Okay, then you take the output of that diode detector is sent to VSWR meter, or sometimes it is called SWR meter. Okay, via coaxial cable. Okay, so yeah, so you could see this is your VSWR meter. So yeah, and then next to this slotted line section, next to this your slotted line section, uh, you can connect different loads, uh, or different kinds of waveguide arrangements basically. So next to the slotted line section, you can actually connect uh, sort you can actually sort your waveguide. You can actually keep it open, or you can actually connect matched load, or you can connect different types of irises or different other microwave components. Okay, based on which experiment you are doing. Okay, so okay, so here it is like a sort plunger for load matching. Here matched load is connected. Okay, so next to the slotted line section, here in this case matched load is connected, but you may connect sort load as well, or you can connect nothing to it. You can keep it open, or you can connect some irises and then matched load as well, depending upon which experiments you are carrying out. Okay, I mean, Bhanu, can you? Yeah, this is. Wait. Uh, Yeah, it has. Banu has also shown that how does this part, like detector part. So you have that square law device, which is actually the crystal diode, and then followed by low pass filter. Okay, so you will get finally the message signal. Okay.
So the VSWR is like what, 1 plus mod gamma L by 1 plus mod gamma by 1 minus mod gamma, right?
Yes, yes. It is.
So how does this measure the like from the slot? Like how does it measure the like gamma? Like what ratio does it measure like exactly?
Wait.
Hello. Hello.
Yeah. Yeah.
Hello.
Yeah. Bhanu.
Am I audible, Mani? Okay.
Yeah.
I mean, VSWR meter. You see, VSWR meter. I don't go by the name VSWR. It won't be showing you directly the VSWR value at one point. Okay. It is just a power meter. You can think of it like that. And the process of measuring the standing wave ratio is quite different. Like you have to move along the waveguide. You have to move the probe along the waveguide, and that VSWR meter, it will simply give you the power levels at a particular point. Okay, once you move from one point to the other point, the meter reading will change, and the difference between the reading will give you the VSWR. Okay, I will try to show you the picture of the meter on the VSWR reading. What I mean is that the VSWR meter, it will just give you the the difference in at one point you will be keeping your probe and you will try to adjust or note some values on the reading, and when you move to the minimum value, from that value the variation in that reading will give you the actual VSWR. I will try to show you the reading. There is a serious lag, I guess. I have already shared the picture, but it's not coming. Am I audible or my voice is
Okay.
also lagging?
Yeah. No, it's audible.
I have already shared the picture, but it's not showing on the shared screen. There is a serious lag.
It's the actual picture, na Bhanu, of the PSWR meter.
Yeah.
Okay.
This, I'm mainly concerned with the scale reader.
Yeah. Yes.
That's what I want to show. There is serious lag.
No, but it's not properly visible. Yeah. So this is how it appears. You may find the black colored part may also like come in blue colored, in as you have seen previously. All the instruments were blue colored or sky blue colored. Okay, but however it will